Good morning, year 7. So, today we're going to talk about the concept of accuracy, and more specifically, the concept of accuracy in measurement in maths. So, all measurements are always correct, aren't they? No. Let's take a very quick example. For instance, shoes. We're going to the store to get shoes. We have to try them on to make sure they fit. How come we just don't stick with the size that we always know? Well, besides the fact that we're growing, when we reach a certain point, like me, my foot does not change size. I am size 10, usually. But I still try on shoes because sometimes they're too small or too big. I need to try them on because these are rounded or slightly inaccurate. They're not calibrated exactly the same. No one's foot is exactly the same size. That's why sometimes in the real world, they round things off, make things slightly less accurate. Okay, so let's apply that to a different model.
Here we are, and this is one of our desks in the classroom. I'm going to get the area of it. Okay, so let's use my ruler. You see here, I've started it at 0, and then it finishes at 49.5. So that is the length. And now I'll measure the width. So remember, we had 49.5. Now measure the width. Measure it up. Okay, there's the mark for 50. Slide it along to the mark, and we get 29. So 49.5 and 79 when I add the 50. Okay, so let's work that out. 3,910.5 centimeters squared. Okay, so is that result accurate?
So, how accurate was it? Probably not very accurate, but how do I put a number on that? First of all, reasons for inaccuracy was my lack of precision when measuring. Now, I used a ruler, and if we look at that ruler, not sure about that ruler. It is not very precise for a number of reasons. It only goes as far as millimeters. Perhaps I could use nanometers. That'd be more precise. Maybe I could use an electronic measurement, so it's perfect. Also, I moved it by hand. Did I check? Was it perfectly straight? No. Another reason. Perhaps you can think of one now. The edges of the table were curved, weren't they? It wasn't a rectangle, yet I used the rectangle formula. Why? Because it's the most like a rectangle of all shapes. But the edges are curved. Would that add or subtract from the area? Probably subtract, wouldn't it? Because those curved edges are missing. So the area is probably slightly less than the area we got, 3,910-ish centimeters squared. So perhaps I could adjust for that and subtract an area. Now, how do I work out that area? Well, that's where a lot of difficulty would come into a question like this. I would have a straight edge corner like this, when actually it's rounded. I've made a presumption that it is straight edge when I use that formula. But that formula is not accurate because there is an area here that I need to subtract. How would I work that out? Well, I'd have to find out the area of the circles and then subtract from the area of the squares, which we'll be doing later on in this unit. But we can definitely draw attention and make an estimate, perhaps using a ruler. Maybe it's a centimeter by a centimeter. Maybe it's just taking off a centimeter squared. Now, the concept of accuracy in measurement is how accurate do we need the answer? For instance, if each of those little corners of the table was 1 centimeter squared, that would mean my answer was off by 4 centimeters squared. How precise is that? How accurate is that? Well, I can go to a formula and turn it into a percentage for help. So that's 4 centimeters squared out of an answer of 3,910.5. So I can turn that into percentage, how much my error was. It's called percentage error. So this is the error, how much I was off, and that is my actual result. Okay? Oh, sorry, that should be 4 less, because the actual result would be 4 less, wouldn't it? So let's take away 4 from that. And that's the actual result. That's how much I was off. I was off by 4. So my percentage error, if I turn that into a decimal by doing 4 divided by 3,900, well, that's 0.001, oh, that's about 0.2. I've even rounded that decimal. Rounding, again, lacks accuracy. As soon as I start rounding stuff, it lacks accuracy. It's more accurate when I provide those decimals that my calculator gives me. That's a more accurate result. But are they usable? Do we really care? Because I'm going to turn this into a percentage. I'm multiplying by 100. So I multiply by around 100. So a quick way of doing that, we should know. Move the decimal place 2 spots. So it's 0.102%. So I'm not even 1% off the correct answer. So how accurate was I? I was accurate. Could I put a percentage on it? Sure. I was about 99.9% accurate with a 0.1 degree of error. So I made slight errors. But in the real world, coming back to the shoe, does it matter how accurate I am? For some people, yes. For shoes, perhaps not. They can be very happy to round off and take average answers. If you're doing electronics, maybe making a computer or something, circuit board, how accurate do you need to be? You need to be pretty accurate, almost 100%. What is 100%? Do we go down to the nanometer, micrometer? How small do we need to go? Perhaps in computer technology, we need a very, very small degree of accuracy. Shoe manufacturer, maybe 1 or 2%, 5% off. What happens if you're building a house? How accurate do you need to be? You always see the guys with the levels to see how accurate those walls are. But when they're measuring, they might measure twice. To what degree do they go to? Did they go to nanometers? Did they use rulers? Did they use meter sticks? Did they use trundle wheels where you wheel along and count the number of clicks for each meter? It depends. So that's where accuracy can become interesting and bring in some maths into it. How accurate we need to be. So, your challenge. I want you to measure a table in your house. Pick a rectangle or any rectangular object, preferably a table. How accurate are your measurements? Perhaps you can draw a diagram in your book again of the top of the table. Measure, measure, and then criticize your own work. How accurate is it? Try and come up with 3 inaccuracies. Why it is inaccurate. If you want, you can attempt my percentage error formula, which is the error divided by the actual answer you think it is, and then multiply that by 100. If you want, that's a challenge. Also, you must do the Kahoot that I've set you, and that is not going to any reports, it's just a fun Kahoot. Just try it based on some measurements. I'll be available on Google Hangout. If you're really stuck, you can email me and I will turn it on. Otherwise, I will see you guys on Friday.